Okay, Mr. Sam, we are back now.
Welcome back. I'm sure you had a well-deserved break. So now we can move. Are you there, Maria? Yeah, Maria, let me introduce you to the participants. I have this pleasure. Maria Devi, a PhD, is a consultant at the Disaster Risk Reduction section of the UNSCAP. She conducts analytical works in this section, particularly risk assessment and impact-based forecasting by utilizing various socioeconomic data. She completed her PhD in urban engineering from the University of Tokyo in 2018. Prior to this, she gained extensive experience of project management and research in disaster risk reduction and climate change adaptation in Bangladesh, Indonesia, Japan, and the Netherlands. So thank you very much. I'd like to welcome you, and Dr. Devi will be providing a hands-on session on developing impact forecasting developing impact forecasting based. I think there's something wrong with the way it's written here. It's a hands-on session on IBF for focus products. Okay. So welcome. You are muted.
Okay, sorry. Thank you very much, Sam, for the introduction. Good afternoon, colleagues. I'm Maria. I'm working with Sanjay and Sangan in DRS and ESCAP. And today I'm going to deliver a presentation on impact-based forecast for Vietnam. First of all, let me share my screen. Yeah. So, as Sanjay and Sangan mentioned previously, we've done several impact-based forecasts for several sub-regions, and then I'm gonna sum up the concept of risk assessment in GIS, that basically it's combining the hazard, exposure, and vulnerability, also adaptive capacity to find out the risk or the impact-based forecast of certain area, also to locate where are the most vulnerable population. So for the hazard data sets, we're gonna use the cyclone forecast data and the seasonal forecast. And for the exposure data, these are socioeconomic data that we could get from a public source, such as from Global Assessment Report, and then CISN, World Pop, and the others. And this gridded population data are measured in 1 kilometer or 100 meters squares. So it's very detailed, as you can see here, the Vietnam population in 2020. And you may also use the population data that are obtained from your statistical division, for example. And we also use infrastructure data, for example, power plants, and then highways, airports, and ports, and agriculture production, for example, seasonal crops, and then agricultural land. For the vulnerability and adaptive capacity of population, there are varied options. The first one.
Maria.
Pardon?
My colleague had question.
The comment slide.
Oh, yes, sure. Is it this one?
Yeah. No. Yes, that one.
Okay.
Please at the island, including my government regulation. Please at the Hoàng Sa and Trường Sa.
Ok này được rồi anh ạ, không. Okay. There's some question I will raise and give to you back, and please continue.
Thank you. So I'll proceed further. The second data sets are vulnerability and adaptive capacity data sets. And there are various types. The first one that we used here is the Subnational Human Development Index as a composite index that consists of life expectancy, education, and also health or economic income. And there are also some other data sets from demographic and health surveys that are available for several countries. And we can also indicate the most vulnerable age in the population, like the elderly population. And for the agriculture sector, for example, proportion of people working in agriculture. And the other data sets are related to water, like water stress and the river basins data. We can use two types of softwares. There are also some others, like ArcGIS or QGIS. The QGIS is a free software that we can download and install it easily, and we can use it freely as well. And to process the data, we also need two other statistical statistical software like Excel and SPSS. The data sets that we are using mainly consist of vector, raster, and delimited text layer data. I'll explain this later. And if you have some question, feel free to ask at any time. The second part is the impact-based forecast using seasonal forecast data. As Sangun mentioned previously, this is the concept of impact-based outlook. In this part, we're using three types: the hazard or climate data, that is precipitation data from WMO for December, January, and February, and then exposure data of population, agriculture, energy, and water, and vulnerability data like Human Development Index. So those are adapted from 5 priority areas of WMO Global Framework for Climate Services. First, let's go to the precipitation data set. On the left side is the precipitation data downloaded from WMO website. We can see here. So this is the website from WMO. It consists of probabilistic model of climate. From here, I chose the ensemble model from various climate centers. You can also modify those and then select the time range that you wish. And the first tab, we have to redraw the climate data set into a shape file. I'll show you in the software. So here's the QGIS preview. You can see all of the toolbars here on the upper parts, and then the left part shows the layers of data sets that we are using. And on the right side, you can type the command to operate the functions. The first one, I'm going to show you the dataset from WMO. It's here. This is the original one. So you can see, we could see that it's available for the Asia Pacific areas. And then what we did after that is redrawing that one, especially for Vietnam areas. And I insert the province boundaries. So this data set of precipitation consists of 4 layers, 1, 2, and 3 category that explain that explains the percentage of probability. So wait a second. So the light blue shows 40% above average, and then the dark blue shows 50% above, and yellow shows 40% below average. That means the blue part will have more rainfall, and the brown or yellow part will experience less rainfall. So the second data set that we will work on is population data set. Here I'm using Vietnam population for 2020 at 100 meter at the equator resolution. So here's the WorldPop website. You can download various types of population data. For example, here we are using population counts. There are also another data sets like age and sex structure to find out the elderly population, for example. And they also have global settlements or population density. So in the population data set, population counts, it has various types from the 100 meters to 100 kilometers resolution, and we can select the countries directly from here. For example, this one. So for Vietnam, it's available from year 2000 up to 2020. So the other countries are the same. And we'll be back to the PowerPoint file. And the first thing to do is to clip the population data set. So first of all, we have the population data on the left side, and then the hazard data or the precipitation data on the middle part. And then by doing a function that is called crib raster by mask layer, we can indicate the areas where population are affected. So this is the final file that we are going to quantify. So the thing that we would like to use after we have that file is doing zonal statistics function to find out how many people are located in the zone of 40% below or 50% above and 40% above. Let's see the GIS file. Oops. This is the actual population file that you can see. And then this is a clipped file of population. So we will calculate this by using that zonal statistics. And after operating that function, we will find that data here in the precipitation layer. It's a shape file. And we can open the attribute table here. For example, the area number 1 here, we can see the yellow part, which is 50% above normal precipitation. We can find the sum of population, the total number of population in those area is this one. So we can copy this value to an Excel file. Likewise, for the other areas, like areas number 2, we can see that square here, and there are 2 parts. Part 3 here, and the low precipitation area in the north. That's to calculate the exposed area. And we will calculate the total population here. So these are the total population, and we use a boundary from this world map here. So by combining these two, we can find from the world pop area layers the value of population count is available here. And then we can do a basic statistics for fields and then operate here the Vietnam boundary, and then we can choose some, and then the statistics will appear as we may see on these slides. So the basic statistics for fields result will show like this. And once we get all of the numbers, we can get a percentage of each exposure. So for in the north part, 31% of Vietnam population might experience less precipitation, and in the central and south parts, 58% of total population may experience high rainfall. Would you like to have some questions or translation?
I have a comment before we go to the floor.
Yes, please.
It's concerning the southern parts, the northern parts, and the central, where you have shown the higher and the lower amounts of rainfall. Just to be clear, we are talking about above normal or below normal, not really less or more rain. Am I right?
Yes, you're right.
It's above normal, and okay, because there's a difference in terms of nuance. Okay, perfect.
Yeah,
Thank
it's
you.
above and below normal.
Yeah, okay, thank you.
Yeah, thank you. And the third data set that's related to vulnerability is Human Development Index. Here we get this data from UNDP that's available at subnational level for all countries. We can see it from the website. Here's the website, and you can choose for Vietnam. So it's available at regions level, not province. It's also indicated from 1990 up to 2018, the most updated one. We're using the 2018 data for this. So all of these areas, we can calculate and multiply those to find out where are the most vulnerable people in the location. So here, if we open that file, this is the subnational HDI for Vietnam. The darker color showed lower HDI, and then the lighter color shows a higher HDI. And then when it overlaid with the precipitation data, the north part that has lower HDI, this area might experience 40% below normal precipitation. Also the southern part. So those two regions may need more attention. And another option of data set that might probably available in Vietnam or in your own country probably is the wealth data set. Here we are using the DHS data set that are available for Cambodia, and it shows the wealth data sets from the low to high scale, and it's basically available at clusters level or households level. So we can indicate the location of poor population here. If you may see the red dots, it shows the poorest population that are living in this country. And then we can do an interpolation method to smoothen the areas like this one. From an Excel file types of data to points data in GIS, and then we can get the smooth areas for the final file to calculate with the exposure, with the hazard data. The third data set related to the exposure is value of agriculture production. Here we are using FAO files that is called Global Spatial Disaggregated Crop Production. That's available from this website. This is the FAO's website. You can explore further, and the data sets are available in several formats: GeoTIFF, CSV, and DBF. And it consists of value of production. These are the data sets we're using, and then the production in million tons, and yield, also physical areas and harvested areas. And the most updated one is the 2010 data version 2 that is released this year. You can download the data from here. So what it looks like in the GIS file is this is the value of agriculture production. So you can see on the legend here, the value is in US dollar from 0 up to more than 30 million. So here we combine this data set with precipitation data to find out how much value of agricultural production will probably impacted by lower and higher precipitation. Here we are using the same method as the way we calculate the population data, and we can get these results. 25% of population, especially in the north part, may experience 40% below precipitation, and then 65.9% in the central part and south parts of Vietnam may experience 40 and 50% rainfall above normal. So this is the agriculture production data as the fourth data set that we are using. It's also taken from the same website. Like this, but it's available in million tons unit, so it's slightly different with the agriculture value. If we calculate those and overlay it with the precipitation data, it will look like this one. And the result is this one. 25%, 0.6, and then 66% for the 40 and 50 below precipitation. Another type of data set that we found is the one from Vietnam Ministry of Agriculture that has been using the land use maps and land cover maps to conduct baseline survey for assessment of less flood zones and the recent activities that they have in agriculture development and climate change adaptive agricultural livelihoods in the coastal districts. So by cooperating with the other land ministries, we can get further data sets that is more detailed and to produce a better impact-based forecast. The fifth data set of exposure that we are using here is the energy power plants. As we may know that hydropower plants are sensitive to water, so we can indicate where are the hydropower plants that are sensitive to drought in certain areas. Here's the website of the Asia Pacific Energy Portal in 2019 and 2018. So for Vietnam, as you may see here, we can click one by one to find out the capacity and the units of each power plants. So those data sets are available in CSV files or points data or Excel file, and it can be exported into GIS data, like points data here. And then we can see it from the GIS file. This is the energy power plants. As you may see, the color indicates the capacity of the power plants. Those are the total power plants, and these are the hydropower as the majority. Oops. So by calculating those, by using values in the design capacity column of each power plant points, we can calculate the total numbers here. For example, in the square number 2, we can have this total capacity and then the number of power plants as well. And the final map looks like this, with the percentage calculation of 57% of all power plants that are exposed to 50 above normal, and then there are 1% that are exposed to 40% above normal, and in the north parts there are 22% of power plants exposed to less precipitation, or 17% of the total capacity. Those are the total power plants. How about the hydropower? The hydropower plants exposed to low precipitation, or the north parts here, are almost 40% of the total hydropower plants. This infrastructure exposure not only limited to energy, but also we can try for ports and airports, hospitals, and healthcare facilities, for example, that are prone to flood. Would you like to have some questions or translation?
During the presentation, I also translate for the college, and maybe I take the time for colleagues to raise a question. Anh chị có câu hỏi đúng không ạ?
Okay, thank you. Can I proceed further?
Maria, there's no question now. Thank you so much for
Okay.
the presentation.
Okay, I'll continue to the third part. The third part is the impact-based forecast using cyclone forecast data. As we may know, that Cyclone Nangka occurred from 11 to 14 of October, and we're trying to get the cyclone forecast maps that are available. Here we are using the data from regional and mesoscale meteorological brands of NOAA, where we could see the cyclone tracks are available from October 11th up to 14th for every 6 hours. Here I'm going to give an example on redrawing the cyclone map from scratch up to this one. So this is the 14th October. This is the 13th October data on the bottom part, and this is the 14th October data. After redrawing that file, we will calculate the population exposure, and I will show you it from the GIS files. So this is the 13 October cyclone file and 14. And this is the actual population data, and then a clipped population data here. And the result of this calculation is, as you may see here, the highest wind speed may affect 2.7%, and it increased to 12.5% in 14 October. Also for this one, the 71 to 90% of wind speed, increasing from 15% to about 21% within 6 hours. So we can find those percentage shift from time to time by multiplying these two values. And then the next part is provinces with lower human development index, which are exposed to cyclone Nangka forecast. We can find on the north parts here. And the energy power plants. Their shift from 43% to 30% within 6 hours, and 21% of capacity to 17% of the cyclone of the air or energy power plants in these orange parts. And in the red parts, it also increased a little bit from the left picture to the right picture. And the highest energy power plants are exposed to the fastest wind speed from 5% to 17% within 6 hours. And the next part is the agricultural value from 13 October and 14 October. We can also see the change of values of exposed agriculture value here. and then the agriculture production can also be calculated. And that's all about my presentation. And we would like to have a group exercise to brainstorm and find out the potential indicators for impact-based forecasts that are available in Vietnam. So would you like to discuss and share with us your findings? And of course, if you have some questions, please also ask. Probably Dr. Lam could facilitate the discussion to fill in these tables. Or if you have some other questions, please let me know.
If I may ask a question?
Sure.
So I see we have a table and it's got some of the cells filled up with some information and some are not. Are you asking that the participants complete where you don't have information, or to even add information even in those cells that have information already? You're muted.
So we'd like the participants to fill in those empty cells, or even add some more data that are specific Vietnam, from, for example, from other ministries or from other websites or statistical data that they have that might possibly be used for the impact-based forecast.
Okay, thank you very much. That's very well explained. Maybe somebody can translate that to the participants. That it's actually that the question is to add information to the cells that have no information, but also to the ones with information. If you have relevant information, you can add it as well. Just to translate that to the participants, please. Hello, Vietnam. Who is doing the translation?
Yes, I do translation. Okay.
Okay, your mic was muted, so I didn't know.
Yes.
Sorry. Okay.
Maria, can I intervene a little bit?
Yes, sure.
Colleagues, so I think this is the table that we can think of. What are the potential indicators that we can add to the hazard information, or even the hazard indicators, hazard information, what we can use for impact-based forecasting for Vietnam. For example, for agriculture, here it is already there, the production quantity or value is identified, but is there any other potential indicators that we can think of? For example, the number of farmers or the number of livestock. Perhaps those things we can think of additional indicators that potentially measure the impacts. I think we can just think of a few potential indicators in different sectors.
Hello, Sam and Dr. Lam. Can I just share a few points?
Yes, please go ahead.
Yeah. Thank you, Sam. Sam, what was presented by Maria is based on the data which are available from the global resources. Particularly, you have seen the data sources. So ideally what we recommend is if there are data available from country-owned sources, I think this can be customized. The whole idea is to customize impact-based forecast methodology, what Maria presented in case of Vietnam, based on country-owned data sets. The data that we presented was from the global sources, which serves the purpose of demonstrating a methodology. But if we have to operationalize this methodology, it will be great if the data, what we call custom data, comes from different ministries of the government of Vietnam. So I think that's the idea we were trying to present. The second idea was we wanted to have a hands-on to quantify the impact, particularly on multiple sectors, based on the global data sets, which Maria presented. In due course of the time, we can think of having some custom data from the Vietnam side to really make it something like a viable, potentially operational methodology in days to come. And my last point, Sam, is our plan was to convert this in form of a guidebook. It becomes our crew is in WMO ISCAP joint publications for impact forecasting in Vietnam context, but from the data available from the global sources. So that was our idea. So Maria presentation can be converted in form of a report or a guidebook to impact-based forecasting in Vietnam context. So these are the 3 points, Sam, I thought I will share with you. Thank you.
Thank you very much. Thank you very much, Sanji, for clarifying that. I think this is a very important step that you have explained. The whole idea is that what Maria presented was from the global sources, which is very good to show that first and foremost you have somewhere to start from in getting the vulnerability and exposure data and having those layers, and then the methodologies of using this data, using even available tools like Excel, the GIS sources, etc., to come up with statistics and be able to communicate information, impact-based forecast information. And now what you're looking for is for the participants to think out which sources from Vietnam, like ministries, like probably the Ministry of Statistics or Department of Statistics, what kind of information you might be able to get from the country itself. And to use this as a starting point to something that can be built on later. So this is very good. So to come back to you, do you want to give the participants a certain length of time to think this out, and then we get a report from them?
Yes, Sam. That's the idea we wanted to flag up in this session, and in the tomorrow concluding session, we can include this as a way forward, a guidebook, and also how to operationalize this in Vietnam context. And in the future, we can take this work forward with the custom data from Vietnam.
Okay, very well. So should we give them like 20 minutes or something, or 10? Or how many minutes would you like us to give the participants?
Yes, you can check with them. Whatever comfortable with us is fine with.
Okay, Vietnam, can we give you 15 minutes to just have a go at this, discuss and see whether you might be able to come up with some ideas? And then at Q2, we can, you can report on your discussions.
Okay, Sam. We are divided for group or one group?
Sorry, I didn't get you.
We should divide for group or only one
Okay.
group?
I think it's easier if you have like 3 groups or 4.
Okay, 50 minutes, huh?
Okay. Okay, thank you very much. We'll give you that time. Maria, I hope that's okay.
Yes.
Okay, thank you. And thank you for that presentation.
Thank you. Thank you very much.
Bây giờ mọi người có thể trao đổi mình
trao đổi trước xong rồi mình có 15 phút mà.
Còn 15 phút nữa là
Okay, Maria. Hi, Maria.
Yes.
Yes, some group have result.
Okay.
Yeah.
My
Could you
group,
please share with us your result?
my group record about the.
And I told him.
Can you hear me?
Yes.
Hello.
Can you hear him?
Yes.
Anh nói to.
Okay. We record about the hazard indicator. First, disaster risk reduction. We should about rainfall, wind speed, and temperature. Inundation. We can get that information from NDMA and HCMM. Second, about agriculture, we should get plant, livestock, aquaculture, fishing boat. We can get the data from Minister of Agriculture Rural Development. Third, we about health, we should number of busy people, vulnerable people, and we can get that data from Ministry of Health. About energy, we should number of people use electricity, number of power, hydropower. We can get that information from Ministry of Trade and Industry. About water management, we should get data about the water index and the source of the data from Montreal. That on.
Thank you very much.
Yeah. Another group add more information.
Excuse me, for the water management, could you please repeat what the data and where from?
We the data of the water index means the BUD, CUD can get data from Montreal, Ministry of
Natural resource environment.
Another group at home, please.
Monroe, okay, fine, I got it. Right. That's Ministry of Natural Resources. Right. Okay. Very well. Ria, you good?
Yes, is there any updates from the other groups? I think that's really good from the first group.
Okay, excellent. First group, thank you so much for that contribution. Let's hear from another group now.
More information, hazard indicator about disaster risk reduction. We comment rainfall, cool wave, strong wind, flood, and thunderstorm. About agriculture, we comment crops and productivity. About energy, I think we think the indicator is dam break.
Excuse me. Let me interrupt you a bit. Maria is taking notes.
I will speak more slowly.
Yes, yes, so that we can collect all the information because it's very important.
Yes, I will repeat my idea.
Okay, very well. Thank you. Thank you.
We have rainfall, heat, cool wave, strong wind, flood, and floods. Yeah, already. And the last one is thunderstorm. Yeah, I think between 15 minutes, maybe we write not all the indicator. We in the example in this lesson, some indicator we can try out, and maybe we will think much more about this. And move to agriculture. We recommend the indicator is crop. Crop and productivity. That is the indicator related to agriculture.
Maria, are you there?
Yeah.
Yeah, under agriculture, yeah.
Yes, all right. Good.
Yeah. Move to energy. The indicators is the dam break and reservoir release. Relate to water management, we have indicators drought and salinization. Yeah, so have you typed yet?
Maria.
Ram, it seems that Maria's computer has some problem. So she just noted that her mouse pad doesn't work.
Okay.
So we are trying to write down whatever we have here. We can listen. If you can help to collect the indicators, I think it will be much appreciated. We can receive and we can fill out the table later.
Okay, yes. So I will ask the participants if they have any additional things, and then we can send you later.
Thank you very much.
Sam?
Actually, can I suggest, if you send me this form, I can put it on the website and then they all click there and everybody puts at their own time. Would that be okay? Or would you like to receive emails?
I think that will be better, I think.
Sorry, that would be fine?
Yes. I'll share this to all of you.
Okay, you just share this with me, and then I'll take this particular slide and put it there.
Sure, Sam.
Okay.
Yeah, I think we can move on. So any other business for this morning?
Maybe, so first of all, let's agree on what we are doing here with this one. Does it mean that we can, because we are coming to the close now, this is the last session if there's nothing else, does it, we can leave it there, and then you can organize, Lam, you can organize for the people from the groups, the representatives from the groups to come in. I'll give you the link. They can come in and add the information after we have closed.
Yes. Okay, yeah.
That's okay. They can do that during the self-guided session. Okay?
Yes.
All right. Now I think I would like to ask whether there's anything from the floor? From the participants?
Chỉ có câu hỏi hay là có gì không ạ? Yes, there are no more questions.
No more questions. From the lecturers, Saji, Sanguen, Maria, do you have anything? Anybody who has anything to say?
Thank you very much. Nothing from me.
Okay, Sanji. Maria.
Thank you very much for participating in this workshop, and I'll share the file with Sam, and then please fill out the charts, and then we'll share back to you.
Excellent. So for me, it's just to say thank you so much to the UNSCAP. You have brought another angle to the approach on impact-based forecasting. I really appreciate that. We have shown how we can take it further from just the short-term warnings to even seasonal outlooks. And that's great. This last presentation by you, Maria, also giving hope in finding data and methodologies of going about applying impact-based forecasting to seasonal forecasts. So thank you so much. So I'd like to thank you very much for that. Having said that, I'd like now to announce that later at around 14 hours, that is 14 hours in Vietnam, that's in about 1 hour's time. We are scheduled Mr. Cyril Honoré from WMO. He's the chief of Disaster Risk Reduction and Public Services branch in WMO. He'll be presenting he'll be doing a 15-minute presentation during the self-guided session. Lam, if you can organize yourselves just to make sure that everybody is there at 14 hours for the CAP presentation.
Yes, and then it will be after the CIP will be the self-guide sessions, self-guide study.
Yes, and then from there we have the self-guided session. There is the building IBF partnerships through communication module, and there you have to log into the Comet platform, and you have a username and password you can use. You might find it already filled in. If it's not, it's provided in the program, which is, and you'll find it there. So, and then you have a good time having a afternoon. So thank you very much, everybody. If there's any announcement you want to make from your side, please go ahead.
Excuse me.
Yes.
I just want to ask about the test. Is that tomorrow morning, or so the participant will do the test, the final test tomorrow morning, right?
Yes, you are right. Yes, yes.
Yeah, because at the moment we couldn't find the link, so is that it will be available later?
Just a minute. I'm trying to collect my thoughts here. Yes, I'll communicate with you on that one.
Okay. Yes, yes.
Okay.
Okay, so now I tell the participant. So chiều nay thì chúng ta có cái bài giảng về cái CAP lúc 2 giờ. Mọi người nghỉ 1 tiếng xong quay lại lúc 2 giờ. Và sau đấy thì đến cái phần tự thực hành thì họ có cái username và password ở trên trang web đấy, trên cái khóa biểu đấy. Mọi người sẽ làm bài tập trong chiều ngày hôm nay. Còn bài test là sẽ là sáng ngày mai.
Mai 9 giờ.
Sáng mai là 9 giờ. Có chương trình tự làm.
Cũng là ở trên web luôn.
Cũng ở trên web luôn. Hiện giờ chưa có link thì ông ấy đang sẽ check, có thể là sẽ có link sau. Tức là ở mai thì nó không giới hạn thời gian, tức là theo tôi hiểu thì là cái test đấy mọi người có thể làm bao nhiêu lần cũng được. Đến khi nào đạt thì thôi, mọi người không muốn làm nữa thì thôi. Nhưng mà sau đấy khi ông kia chữa rồi thì mọi người sẽ không làm nữa, cái link nó lại mất đi. Ngày bây giờ là từ 9 giờ đến có một bài giảng nhưng kéo dài cho có 15 phút thôi. 10 phút thì sau đấy là những bài test thì mọi ai làm nhanh làm chậm thì tùy mọi người, ai thích làm nhiều lần, nhưng mà cái khoảng 30 phút cuối thì là ông kia sẽ chữa. Đấy, ông sẽ chữa. Chấm điểm luôn, nhưng mà sau đấy em làm lại bình thường. Yeah, I think they get, and we will be back at 2 p.m. in 1 hour. Yes.
Okay. I'm trying to look for you again. I've lost you. Okay, now I've got you. Yes. Yeah. The quiz is inside the Comet website. But I'll give you more information. I'll send you an email with more information on how to actually get there. The other thing that I would like you to note is that when you do the quiz and pass, I think the pass mark is 70%, you get a certificate.
Okay, I see. Because some participants have done the quiz already.
Really?
Yes. But we are thinking that it will be another test, not that quiz. Is that another test or that's all?
Which quiz? No, not the ones we did. Not the.
Not the one we did this morning. Yes. Not that one.
No. Another one.
Yeah, we have a link for quiz on math.
Yes.
Yeah. So some participants have done it.
Yeah.
The other one will. Okay, I'll check and see.
And even they got a certificate already. Some of them got certificate already.
Let me see from my report whether I might even get to see what they scored. Let's see.
Chị thấy gọi cho cái user password gì đó. Bài tập có trong cái em có chứng chỉ rồi đấy. Sau này chứng chỉ rồi.
Hello. Hello.
Hello, Sam.
Yeah, well, let me get back to you. I'll write an email to you.
Yeah. I'm also sending the slide to you.
Yeah.
Take your time.
Sorry. Okay.
Take your time and tell me later.
Okay, fine. Excellent.
Yeah. So thank you very much, everyone, for doing the lectures this morning. We it's look very interesting for us to make some more practice, and especially the one with the GIS, we overlay some different layers. It's help us to imagine that what we need to do in future to get a better idea about the impact of the weather hazard. Yeah, thank you very much for your lectures. Thank you.
Thank you so much. Thank you to all the participants. Thank you, Lam, for the translations, etc. Okay. All the best. Bye for now.